All right, guys, welcome to Thursday's class, the last class of the week. If memory serves me correctly, we only have 2 more weeks after this, correct? Your group project will be due, I think it's May 3rd. It'll be the last Friday, not next Friday, but the Friday after that, okay? It'll be due online, and then I'll have them graded for you and give them back to you when we see each other on Tuesday for the final. Remember, your finals in this classroom at 8 o'clock in the morning consist of 2 parts, a 70 multiple choice question and a 30-point hands-on that requires the use of Word, Excel, and Access. I say this just to remind you because starting next week we'll be doing nothing but integration. What I have scheduled for today is we're going to be going over the troubleshooting a network, talk about the different types of mediums that allow our devices to connect together, and then go into PowerPoint to show you how to add your voiceover to your PowerPoint presentation. All right? The program I'm going to show you guys today will not be installed on your home computer. It's used by Cisco network administrators to teach them networking theory. Because it's a tool to use to teach networking theory, I thought it'd be perfect to show you guys basically how to build a network without going out and buying the hardware and running the cabling. So somewhere on your desktop, there should be an application called Cisco Packet Tracer. Do you guys have that? Remember, you don't need to know how to use this. You don't need to have this installed on your home computer. I'm just doing it today to try to create a learning environment for us when it comes to networking. Because remember, the definition of networking devices definition of a network is when you have 2 or more devices connected together to share resources. So when you guys find that icon, just double click on it. If you get the little preference message, just click OK. And then you should be out here, this drawing board. Is that what everybody has? All right, so to create a network, this virtual network, we need to have 2 or more devices. More importantly, we need to have end devices. So down here at the lower left corner of the screen is a picture of a PC. Go ahead and click on that. Then over here in the center area, the tool palette, click on the very first generic icon. It's just a desktop PC. After you click on that once, come up to the canvas, the whiteboard, click once, and you should be dropping a PC on there. PC 0, is that what you guys have? Remember, this is like a virtual network that we're about to create. Do the same thing. Come back down here, click on that generic, and add another one, because we need 2 or more end devices. So you guys should have PC 0 and PC 1. We need to connect them together. If there's only 2 computers, you might be able to connect them together via a crossover cable. That's beyond the scope of this class. There's going to be another device that's going to be used to connect us to the internet. So having a crossover cable to connect both of these together would be rather frivolous because the only thing you could do is share files between just these 2 places, these 2 end devices. So what device should I be looking for? It acts as an intermediary device, more like a splitter for my internet, to connect these end devices to the rest of my network.
Like your router?
A router, today you guys are used to calling it a router because it's usually an integrated service router. It has a switch, a router, maybe even a wireless router built in. So down here, first row, second icon in from the left is going to be a switch. So if you click on that, go ahead and click on this first 2950 icon. You see that dash 24? All that's telling us is that this has 24 ports. So click on that once to come up in the canvas and click on that. Like I said, the dash 24 tells me I have 24 ports. That means I can connect 24 devices physically to this network. What if I have more than 24 devices? I could add another switch, connect the switches together, and then now I can connect up to about 47, 46, because 2 of those ports are going to be lost to connecting the switches. All right. Now we're going to need a router to connect to the internet. So on the very first row, very first icon that looks like a little cylinder, click on that once, and then click on the 1841 router, very first icon. And I'm just going to add that right here to the right of the switch. Now, like I said, when Adam said, well, a router, the home products will usually have these devices grouped together. And then you guys might have a modem to modulate. That's probably going to be changing as we start getting fiber more to the home, and we won't be needing modems to modulate the signals anymore. The reason we have modems today is because we're taking what we're used to transmitting across the local network and trying to transmit them on an existing network, like your telephone network, like your cable TV. All of these are different forms of networks, if you will. So the modem basically modulates the signal from what we're used to on this network to the WAN, the wide area network. All right, so we have these components thrown into my home, if you will. Now I need to connect them together. So we're following the Ethernet standard. That means I'm going to be using a Cat5 Ethernet cable. You see this little lightning bolt? Go ahead and click on that lightning bolt. Now, this tool does not exist in the real world, but we're going to do that. I want you to hold the control key, and I want you to click on the first lightning bolt icon over here in this group. What that'll do is it'll lock that tool. This is an auto connect tool. Like I said, it doesn't exist in the real world. It makes it easier for me because I can click on PC 0, go ahead and do that, and then I can click on switch 0. Auto connect. Now, when I'm teaching this stuff, especially to my networking students, I tell them that's a tool that you'll not allow to be used in Packet Tracer because it doesn't exist in the real world. Let me show you why. Could you guys hit the escape key on your keyboard? Come down here and click on that solid black line. It's the third icon in. Now click on PC1. Do you notice when you click on PC1, you're greeted with a choice? I prefer this. Although this is emulated and it's not like this in the real world, when you look behind your computer, you're going to be looking at all these different ports. Do yourself a favor. When you go to connect your Ethernet cable to your switch, there's only going to be one port that this cable plugs into, one type of a port. Don't force it. When I worked for an internet service provider, we were switching our clients from dial-up to DSL. And they were trying to save themselves a lot of money because at that time, a lot of the computers did not have network interface cards. They thought, well, this cable looks no different than a telephone cable. So I'll just put it right in our dial-up modem. Now, when you go to look at a dial-up telephone cable and compare it to an Ethernet cable, this connector, this terminator, is a lot bigger. It has 8 pins. Your dial-up phone jack cable has 4 pins. Till to this day, I'm amazed that they were able to jam something like this into their dial-up modem. Folks, if it doesn't go easy, don't force it. This is the sound it should make if it goes well. Just a nice little click. Notice I didn't have to get out the hammer to slam this thing in. So when you guys go to connect your laptop or your device to your PC, you want to make sure you look for a port that looks like a glorified telephone jack, if you will. It has a tongue on it. The reason why that tongue is in there is so we position the pins correctly. And it holds it in there. Now when you click on the switch, you see you're greeted with basically 24 options. It truly does not matter which port on your switch you use to connect your end device to. I'm going to click on the Fast Ethernet 0/2. Bless you. And the last thing I need to do is connect the switch to the router. And I got to be very careful about this. So I'm going to come over here, click on that solid black icon again. Click on switch 0. I'm going to choose port 24. I chose port 1 for PC 0 and port 2 for PC 1, but now I'm choosing port 24 for my router. The only reason why I do that is my router acts like a gateway, a way out. So if I use the last port on my switch, I can quickly associate that the last port is with my router, and then it helps narrow down. Now the reason why I bring this to your attention is your homes are going to get smarter. The people that build your homes are going to get smarter. We depend on the network. They're going to be a little bit more self-conscious about where they put things. For example, your circuit panel that controls all the different outlets in your house, is conveniently located in one room. Today, we're doing this ad hoc network. We go out to Walmart, buy this integrated service router or wireless router, throw it anywhere in the house, and we got cables running all over the place. What is the advantage of taking all your networking, all your telecommunications, all your entertainment, and putting it into a rack like this, and putting it in a closet somewhere in your house or underneath the stairs? Let's say it's centrally located.
You lose the information on your one hard drive, you can go to your backup.
Okay, so by having it centrally located and everybody plugged into this one area, you could probably put a server in there that connects to that to do all your backing up. Good. It's convenient because you don't have to run all over the house wondering what computer is causing the problem. You go to this switch, you see these lights, and now you're like, okay, which one is this? Which one's that? This is like your, circuit breaker panel. Hopefully they're labeled. If they're not labeled, what are you doing? Flipping each one of them, turning things off that doesn't need to be turned off. Likewise, here. But the important thing is, it's going to make it easier for you to upgrade. You're not running all over the place checking all these different things out there. Now, I make a point to this because eventually everything in our house is going to be controlled by computers. This includes your outlets. Right now, I have no way of identifying this outlet from that outlet. We call this unmanaged. Now, if you guys go to Best Buy, you'll start seeing that they're selling these little adapters that you can plug onto these outlets that you can control with your smartphone. So it means when you're on vacation, you can actually turn your lights on and off. And why would you want to do something like that? Yeah, to make it look like you're still home. So, giving you a heads up, this thing is going to merge into you, and you guys are going to be using it quite a bit. So when I click on this router, by the way, what I'm trying to say is these home products that you buy, they're getting more intelligent, hence they're going to get a little more complicated. Yes?
I've got the Time Warner smart home.
Yes.
And I can control my lights.
Exactly. Everything. That's what I'm saying. It's getting to that point.
With my cell phone.
Yep. So when I click on this router, you see I have multiple choices now? I'm just going to choose the fast Ethernet. Remember, the router or the gateway is basically connecting two networks together. This classroom's connected by that hallway to the other classrooms. That's a different network than in here. Remember, I told you this is a local area network. You'll see I have a bunch of red dots. If all goes well in the real world, and you go to take a cable like this and hook it up from your switch to your end device and your switch will have lights on it. They'll either go green or orange, depending on the speed of your network. If they don't light up, there's either something wrong with the cable or the interface is turned off. So first thing, when it comes to troubleshooting, check to see if the lights are lit up. If your lights aren't lit up, check the cable. Now the way I do it, or the way I might do it, is I might take one that is working and plug it to the port that might not be working. This way I know the cable is functioning. If the light doesn't come on, then there's something wrong with the port and I might have to buy a new switch. If the light does come on, then there's something wrong with the cable and I have to make a new cable or buy a new cable. Here, I know I'm not going to be able to communicate with the router just yet because the lights are off. So, like I said, step one for troubleshooting, check interface/port lights. Should PC0 and PC1 be able to communicate with each other? Well, the first rule is done, right? First step, I have green lights. Let's test that. Let's click on PC0. Now, the way you would do it in the real world is you would hold your window key, you'd hit the letter R, and you'd type in CMD, and you'd get that black command prompt. Here, we're just going to click on desktop. Then we're going to click on Command Prompt. Pretty close to what we're used to seeing. Remember last week when we did this? It was a black screen with some white text. Now, the tool that we use when it comes to check connectivity is called ping. I'm not going to put that up into the steps, but I'll just write the command up here for you so you have it. Ping space followed by the computer's IP address. Interesting. I want to talk to PC1. In order for me to send a message to PC1, I have to know what PC1's IP address is. So let me close out of PC0. Let me click on PC1. Let me click on Desktop. Let me click on the command prompt. Now I'm going to use another command. It's called ipconfig, all one word. So here at this prompt, I'm just going to type in ipconfig. And I'm going to hit enter. Do you guys have a bunch of zeros in there? Depending on your computer, there might be a bunch of zeros. It might be some number in the 167 range. This is not good. This is telling me that I haven't configured my PC yet. Now, most of the time, our PCs are automatically configured for us using something called DHCP. When you boot up your computer, a device on your network will automatically assign an IP address. This is where it gets really tricky. You guys might have multiple devices, whether it's a wireless router or the box from Time Warner, who has that service running. And both of those services are designed to give out a certain IP address. So half of your devices on your network is getting one particular IP address, and the other devices are getting another. They're not going to be able to communicate with each other. So the second step for troubleshooting check the IP address of each device per device. The way you do that is type in ipconfig. This is, of course, implying that you use a full-blown computer. If you're using a tablet or a smartphone, you might have to go to the preferences of the settings and click on the interface, and then they should show you the IP address stuff. All right, so, this computer doesn't have an IP address. Let's close out of just the command prompt. So click on this little X right here. Somewhere on your computer, there's got to be a way to configure it, whether it's manually or automatic. In this particular computer, it's on this button. Sorry, this simulation. So click on ipconfig. You see I have two choices here, DHCP and static. That's basically what Windows is going to do for you. It's either going to be automatic or manual. In this exercise, we're going to do it as static. Let's click on the first IP address block. Sorry, text box. What number should I put in there, guys? It might be dependent on what your Time Warner router is, or maybe what your wireless router is. So don't get willy-nilly and say, I'm just going to make it this. If you have a device that's already sending out IP addresses or already pre-configured, you might want to find out what their IP address is and try to match it. Since we are creating this network, we're going to go and change all those devices to match our addressing scheme. All right? So let's start off with a number. What's my range? What number can I pick? Between what and what? Zero to what? 255. I'm going to type in 192. What am I going to put after the 192? A dot, yep. Now I'm in another octet. What's my range? From what to what? 0 to 255. All right, I'm going to put in 168. Now, why am I picking this number? This seems to be the de facto Class C private addresses that you guys will experience by going out and buying a home device, like a wireless router, switch, or whatever the case may be. All right, so let's put in a 1 dot, let's make this one, yeah, 1 will do just fine. Hit the tab key. Did it automatically complete with 255.255.255.0? Good. They're telling me that the first 3 octets have to be the same on all the other devices on my network. Is that clear? I said any number that has a 255 underneath it is telling you that it should have that as its network address. So the network address for this device is 192.168.1.0. We're good with that? The other thing we got to follow is no 2 devices can have the same IP address. So the next PC will probably be .2. What about the gateway address? The gateway has to be on the same network as my PC, correct? Hence, the first 3 is already told by what I have established. I cannot change it to anything else without changing these. The last one is interesting. I can't use .1. Why not? Because that's the PC I'm on, right? Could .2 work? Possibly, if no other device has it. I always like to think of my gateway as the last device before anything leaves or comes into my house, right? So I'm going to give it the last IP address of 254. Because remember, the range goes from 0 to 255. 0 is commonly used for a network address, and 255 is commonly used for a broadcast address. So I have this usable range between 1 and 254. So I'm going to make that my gateway. I also have this DNS server. Can anybody tell me what that's about? It's important when it comes to troubleshooting. Why are they asking for that? Do I need to fill it in? Typically on your home computer, you can put in your gateway address as your DNS address. Tell me, folks, what is DNS? Domain Name Service. This is the service that allows us to type in google.com and it'll convert that domain into an IP address because anything that's traveling on the network must use IP addresses. If this is left empty, that might be an issue. So let's close out of that. Let's go back to that command prompt and type in ipconfig again. Do you see when I type in that command, I go from nothing to actually something? Okay, let's close out of the command prompt. Let's close out of this dialog box. Let's go back to PC 0. Let's go back to the command prompt. Now let's type in ping space followed by the IP address of the other device. So after you get the IP addresses, next thing is to ping a neighbor. So ping a local device, and the way you do that is type in ping followed by the IP address of that device. So what was the address for that device? I'll do the hard part. 192.168.1. What are you going to put after that last dot? What was the IP address of the other device? .1. Did it fail? Yep. So that's their equivalent of failing. It means it gave up because it said, hey, .1, are you out there? .1, are you out there? And it's going to try about 4 or 5 times, and if it's not getting a reply, it's just giving up. So we don't have any communication between PC 0 and PC 1. But PC 1 has this IP address of 192.168.1.1. What's wrong? Let's type in ipconfig. And as we can see, I have nothing but zeros. Now, you guys hit the pause button for a second, and let me show you what actually goes on Edit filters, show none, and we're going to do this. And let me come back here. So logically, what I want to do is I want this PC to talk to this PC. So I have this envelope, and when I do it, I'm getting a little red X. And the reason why I'm getting that is the protocol states if you're going to send a message to whoever, you need a source IP address and a destination IP address. This is like you guys trying to mail something in your mailbox and you don't put any addressing information on the envelope. The person who picks up the mail is going to look at this and say, well, that was a fun joke, and throw it back in your mailbox. It's not going to leave your mailbox unless you have both the source and the destination. So let's go back into real time. We need to give PC0 an IP address. So close out of the command prompt, click on ipconfig. What's the first 3 octets going to be for the IP address? 192.168.1. What's the last one going to be? 2? Seems logical. Why were the first 3 192.168.1? Because we have to follow the pattern that we set up on the other PC. Let's click on the subnet mask. By hitting the tab key, does it auto-complete? What are you going to put in for the gateway? 254. There's only one door in this classroom to get out there, okay? I know there's another one, but there's only one to get out there on the hallway. And this will happen on your home computers too, because you guys might be buying multiple wireless routers because your one wireless router can't reach the second floor. And so the wireless routers could act like a gateway. The problem is they're sort of like internal gateways. It's like having multiple doors inside your house. So there's only one door to get out here to this hallway. All my devices, just like you guys, must use that to leave here, correct? So I might as well give that the right information. So number 4, verify that it's properly configured. So verify configuration. Make sure when you're verifying your configurations, you do it for all PCs, and that certain things have a consistent pattern. Same subnet mask, same default gateway, and guess what? Same DNS. Probably should be using the same phone book. Let's close out of that. Now let's go back to the command prompt. Hit the up arrow twice. Did it auto-complete the ping 192.168.1.1? If it doesn't, just type out ping space 192.168.1.1. Hit enter. And did you get replies? Replies are a good thing. That means PC0 and PC1 are able to talk to each other. All right, hit the pause button for a second and let me show you what this looks like logically. It leaves my PC, it goes to the switch reads that information, rebuilds it, sends it out the appropriate port. That PC gets it, needs to respond back to PC0, letting it know that it received it, so it generates a message, sends it back to the switch. Do you see how the switch is like Grand Central Station? Sends it back to PC0. PC0 is happy because it gets a reply, so it shows you a little green check mark. You don't see this in the real world, that's why I use the ping command. If you get request timed out or request unreachable, then you have an issue. Whether it's IP information not being set up correctly, cable failure, or something wrong with your interface card. So, great. Let me go back to real time. What if there is something wrong with the interface card? See here, I had you guys ping the local device using the IP address. But maybe the first thing I should have had you test is to see if the stack is okay. Sometimes we get viruses. If a virus can embed itself in the stack, it'll act almost like the switch, and that is any information that's leaving or coming into your computer, it'll read first. Folks, when you enter your username and password, That's information that starts up here at the software level, and it's got to work its way down to the stack. If that information is right up here and before it gets encrypted, which happens down here, I'm going to embed my virus right in the middle. If a virus has to read the information, it's going to take time for that message to get from the source to the destination. Sometimes things give up because they are time sensitive, because they have a security issue. So when you ping things, another thing you should ping in here is called the loopback address, which is going to be ping space 127.0.0.1. In fact, that's probably should be the very first thing you ping before you ping anything else. The loopback ping checks to see if the stack is properly installed. If it fails, you have something internally wrong with your computer, whether it's a virus or a poor driver being installed. Don't call your ISP up unless you want them to come out and fix your computer and charge you $100 an hour, okay? That's why we call it the loopback or the local ping, because what it's doing is testing your software. The next thing you want to ping after you do your loopback is your own IP address. The self IP address. The reason why you want to do that is because you need to check to see if your network card is functioning. That is to say, if it's firing out those electrons on the cable. If it's not, then you might have to buy a new network interface card. Okay? So those are two things to check. If those two pass, then ping a local device. By pinging a local device, did you see how you were able to test the cable, then the switch, then this cable? If that failed, it might be that you don't have the right IP address. What else could be the conditions if you tried pinging this device and it failed? What do you guys think? So if you tried pinging here to there and it fails, you already ruled out the IP address. What else might be? Could be the connections. What else could it be? Could be this intermediary device, right? If that happens, I suggest you unplug the switch, let it sit idle for a little bit, and then power it back on. Have you guys experienced this with your wireless routers? It's all of a sudden gets slow and it's dropping these packets. Well, your wireless router is getting a bunch of electricity through it, all these different packets, and it's going to overheat. We never think about this. We never give it a break. We never turn it off before we go to bed. We always want it to be running all the time. And that means it's listening to the airwaves. Whether somebody's sending a packet or not, there's always something going on in the air that we can't see, that those antennas can detect, and it's constantly processing it. So these routers get overworked, hence they get really hot, and sometimes they need to cool off. So if you power them down, give it a couple of minutes, maybe a few hours, depending on how hot it is, let it cool off, turn it back on, see how well it works. If it's back to working the way it was, then that's all it was overheated. Now, this heat can cause damage. These wireless routers only go for 50 bucks, maybe 100 bucks. They're designed to be throwaways. They can probably get you through 1 year of aggressive internet traffic. Throw them out, you buy a new one. If you're tired of replacing your wireless routers, then you have to buy a high-end professional grade one which has a cooling fan built into it to keep it running. Okay? So try that. This is what happens. Switches, wireless routers, the whole 9 yards. They don't cool off properly. They're overworked. Turn it off. Give it time to cool off. Turn it back on. See if your ping works. It might work for about 5 minutes and then go back doing the same thing. If that happens, what do you guys think you should do? Turn it off for 5 minutes, let it cool down, turn it back on. It works for another 5 minutes, and then it goes back to acting like it was. Throw it out and buy a new one because it's physically damaged. Okay? What if that wasn't the problem? No matter, even if you went out and bought a new one and you plugged it in here and it's still doing the same thing. Focus on where the message is going. Right now, all we've done is local test. If this works and this fails, check this. If both of these fail, in other words, folks, just don't try one local device, try several of them. If both of them fail, then it might be the switch, or it might just be you. So go through this process. Ping this one. Great, it works. Now let's ping the router. What's the IP address for that router? What's another name for a router? The gateway? 254? So let's open up any one of the PCs, go to the command prompt, and ping 192.168.1.254 and hit enter. It will fail, but this time, why will it fail? The first time when we did something like this, it failed because the PC wasn't properly configured, correct? If you type in ipconfig, you will see that this PC is properly configured. So why is it failing now? Our router isn't configured. It's got to be both devices, right, folks? Let's close out of the PC 0. Let's open up router 0. Folks, I'll guarantee you your router does not look like this. In fact, your wireless router, the way you go to configure it, it'll probably be via a web browser. This is where the challenge comes in. And this is what I tell students to do all the time. When you buy your wireless router, find a computer, unplug your computer from the network. In the box, when you buy your wireless router, is going to be a cable like this. From this, plug it into your PC. On this end, plug it into one of the ports on your wireless router. Now turn on your computer. That wireless router will automatically hand out the IP information for your end device. The next thing you need to do when that happens is you go to your command prompt and type in ipconfig. You will get that default gateway, and that's going to be a number. Write that number down. It might be 192.168. something. When you have that number written down, open up your favorite web browser. Type in that IP address in the address bar. When you do that, you're going to be greeted with a username and password. In the little instruction manual that came with your wireless router, it will tell you what the default username and password is. It's typically admin for the username and maybe admin for the password, or simply password or left empty. This scares the hell out of me because there are websites out there that have the most commonly used passwords for wireless routers. If you do not change this, then your neighbor can do the same thing I told you guys to do. Get into your wireless router and install things that could snoop on your network. Change your default password, okay? It'll be a step-by-step once you get in there. What we're learning now is very applicable to what you do there. It will not look like this. It'll be very user-friendly. It'll be a wizard to walk you guys through it. However, we're going to do this because it's just simulation. Click on Config tab. Click on the Fast Ethernet 0/0. After all, that was the interface that we used to connect the switch to the router. You see it's turned off. Turn it on. Down below, you see it says IP address. Click on that box. Type in 192.168.1. What should the IP address of this device be? 254. I am now giving a device on my network this IP address that's going to act like my gateway. All right, click on the subnet mask box. Did it automatically put in the 3 255s followed by a 0? Good. Close out of the router 0. Do you see how this light's blinking now? Then it finally went green. They're negotiating with each other. Green's good. Go back to PC 0. Go to the command prompt. Click on, type in ping 192.168.1.254, and it should work. What if you checked everything and you still can't ping? The wires are right, you went out and bought 5 brand new wireless routers and they're all failing, or you have all new computers and they're failing. But the loopback work, the self IP address work, but when you go to ping another local device on that network, it fails. Let's think about this for a second. In order for the ping command to work, you are sending a message. That message is knocking on that end device to see if they can come in. If it replies back to you, that means that message gets in there. There's this threat called denial of service attack, and it's just a glorified ping command that bombards a server with these silly messages. By bombarding the server with these silly messages, the server's monopolized. That means it can't take care of anybody else but the person who's pinging it, hence the denial of service. This is like somebody in your class raising their hand and they just go on and talking and you can't ask your question. So there's got to be a way to block pings. If you try pinging a device and it fails and you did all the other due diligence, the next thing you need to check under verify your configuration, check to see if you have a firewall installed. On my final exam that I give my networking students, I make sure that firewall is turned on and it's designed to be a real pain in the ass when it comes to pings. And I don't know how many of my students will go through all those things, checking the loopback, checking local addresses and so on, and fail to realize that the firewall is blocking it. In fact, last Thursday, you guys remember we had a problem logging in and getting out on the internet? They installed something new on the network, and guess what that something was? It was a firewall. They installed it on our server, and it was designed to block everything. Everything. Authentications, hence you guys couldn't sign in or took forever. Internet connections, file sharing. These aren't things that you want to do for your server. These are things you might want to do on the end devices. So we fixed it. We turned off the firewall. Is it a good idea to turn off firewalls? No. Inside those firewall services or applications, there's a way to add rules that allow certain traffic to come in and go out. Have you guys ever worked with your firewall? Maybe you've tried to use this application that said your firewall's blocking it, or maybe it might pop up saying, do you give this application permission, and if so, how long? These are you making exceptions to the rule, okay? So, that works. Let's see if we can ping Google, though. Ping space www.google.com. What makes this ping different than the other pings? Yeah, it's not in my local area network. So now I got a whole nother set of things to check out for. First of all, I pinged not an IP address, but a domain, correct? The first thing this should have done is taken that domain name and converted it into an IP address. You guys can see this. Hold your window key, hit the letter R, type in CMD, and click OK. You have that real DOS command prompt now. Type in ping space www.google.com and then hit enter. Do you notice you're getting replies from an IP address now? This is one of Google's IP address. Looking at the other fake DOS command prompt, I don't get any replies from the host. Do you notice I'm not even getting requests timed out? I'm getting absolutely nothing, but in the real world, I am. That's because something's working in the real world that's not working here. Anybody want to take a guess what it is? Think about this. We're no longer pinging the IP address. That's what we use for straight-to-straight conversation. The difference between these two is like when you hold your Siri button and you say, call Bob. In order for call Bob to work, there must be somebody named Bob in your contacts. Is that right? The opposite is call, then the number, right? 607-962-9564. The difference is one's more of a direct approach. Here, when I ping an IP address, I'm dealing directly with the host. When I ping a domain name, I'm not dealing directly. What must work in order for the domain to be resolved to an IP address? You got to check to see if your DNS works. One thing is if it's properly configured. If your local device is configured to have a DNS address. If your end devices do not have a DNS server address, then it won't be able to resolve it. Number two, the service is running. Most of the time, your DNS is routed to your ISP's DNS. The way you can track that is using a command called nslookup. That's short for name server lookup. When you're at your DOS command prompt and you type in nslookup, space, put in the domain name, google.com, and hit enter. It should give you all the IP addresses associated with that domain. If it's not running, this will not come up. It will fail. What can you do about that? First thing is properly configure it so it's the IP address of maybe your local gateway, or you use something called OpenDNS, which is a Google DNS, and put that in there. If that doesn't work, you need to check your internet connection. How do you check your internet connection? How did we check our local connections? We ping a device, right? Can you guys give me a device that's on the internet that I could ping? Any one of these IP addresses? It might be just so you have these for your own personal notes, because if your internet connection's down, you're not going to be able to get this. Or if your DNS connection's down, you're not going to be able to get this. So you might want to write this somewhere, maybe on the bottom side of your wireless router, to have some publicly available IP address that you can ping. Because folks, when it's down, this is the only thing you could use to test that. Or you call a friend up and be like, look, can you ping Google and tell me what the IP address is so that I can ping them? So let me try that. Let me ping 173.194.46.32 and hit enter. And I got replies. So, step 6, this is to check your internet connection. Ping a public IP address. If you get replies this way, but you get failures when you ping the domain name, that should tell you that you have a problem with your DNS, correct? If you get replies with this, it should tell you that your internet connection's working. Because the only way you can get that reply is when it leaves your when it leaves your router, travels through your cable connection or your fiber or your airwaves, whatever the way it is you're connected your house to the internet, arrives at the destination, and comes back. So if they work, do not call your ISP and say, my internet connection's down, but call them and say, I'm having a problem with my DNS. But repeat these steps. Go to another local device and do the same thing. Ping Google. If all your devices on your network cannot ping google.com, but they can all ping the IP address that represents that, then call your ISP up and say, I'm having a problem with the DNS server. Okay? What if this fails? Both of these fail. Pinging google.com and then pinging their public IP address. You can ping your gateway. That works. So let me close out of some of these things. Everything up to this point works. Anything beyond this point fails. Is there anything you can do in your power before you call your ISP? Because folks, what they're doing now is if it's your fault, if there's something wrong with your equipment, you're going to get billed for that time. So you need to make sure that when you call them, you feel 100% confident that it's on their end. Otherwise, when you go look at your bill, it's going to be like an extra $100 just for that telephone conversation. What's the last thing you can do before you call them to verify that everything is kosher on your end? Your ISP is going to give you some type of device. We call that the modem. On that device, there's going to be some more lights. There's probably going to be like a status or a link light letting you know that your modem is connected to their office. If that link light is not on, and everything else up to your point is good, check your surge protector. You might have an electrical storm, it blew out the surge protector. That means the connection between their office and your modem is broken because the surge is blown. The surge protector is blown. Okay? Plug it directly in, see if the link light comes in. If it does come on, simple, go buy a new surge protector. If it doesn't come on, then you call them. Because from the point from your house to their office, there's something wrong. If the link light is on, turn off that device, give it a couple minutes to cool off, turn it back on. If it's working, and then it goes back off in 10 minutes, you might have to call them up and tell them, look, you need to replace your router or modem, it's overworked. Making sense, folks? Do you see these 6 steps to follow through just to cover your own end? All right, the last thing I'm going to teach you is called a traceroute command. All this could be on, but you're trying to get to a particular site and it's failing. Now you need to know where the blame is at. Last semester, or maybe it was a year ago when we had that flood, I guess it was a year last September, is that right? When that storm came up the East Coast, it knocked out my IT lab, and their servers were down in like South Carolina or North Carolina, and everybody's internet connection was working, but when they went to go on the My IT lab, it wasn't coming up. And so I told my students what to do is what you guys are going to do right now is run this traceRT command. So number 7, do a trace route. All one word, followed by the address. So I'm going to type in trace RT space 173.194.46.32, and I'm going to hit enter. I love this. These are the number of hops. Remember, our router is connected to another router, which is connected to another router, which is connected to another router. This is tracing all the different routers that my packet's going through. So I go to 192.168.1.1. That's my gateway. That's the first router. From there, I go to a 10.112.128.1. I don't know what that is. It looks like that's a Corning server. Then it's going to go to Northeast Roadrunner. Is that where everybody else got to? So this is where my Time Warner connection is. From Time Warner, it's going to timewarnercable.com east. This must be Binghamton. BGM. From Binghamton, it's going to their backbone, which I have no clue where it might be at. It might be in Albany. I have no clue. I could take these IP addresses and Google them with Google Map, and they can tell me exactly where they're at. But it took me 11 attempts to get to that server. Did it take you guys 11? Some might take 12. Depends on different times you run it, because you don't take the same path each time you get there. But the cool thing is I get to see where it's going. If it stops right here and it doesn't go beyond that, I'm going to get a bunch of little asterisks, and then eventually it'll time out after 30 tries. That means I know that this server is having a problem. And the important thing is I know it's not me. Because I'm up to this point right here. Once it gets to here, it's out of my house. I know it's out of my house because I can just read the domain name, and it says RR, Roadrunner. Nice little tool. I'm not expecting you guys to understand all the different components of it, other than you can see where it's tracing, where it's going to, and if it fails, it's not going to be able to do the rest of it. You'll get success when it says complete. In this case, it took 11 hops, 11 routers. Folks, I don't know about you, but that should open up your eye to realize that everything you send out on the internet is being passed around to all these different devices. What's to stop somebody in one of these places to put a packet sniffing software on there and say, hey, I see so-and-so is looking at this, I see so-and-so is doing that. Nothing at all. Your best thing to do is you encrypt your data before it leaves your computer, so when they do get it, it takes them forever to be able to crack the code, and by then, that information's obsolete. Hence, change your passwords often. But how often do we change our credit cards? By the way, you can take your computer and maybe a bunch of computers in your house and connect them together, and you can crack some of these algorithms in maybe 2 or 3 years' time. And as computers become more and more powerful, what do you think is going to happen to how fast it's going to take to crack them? You're going to be able to crack the encryption a lot sooner, correct? So my question is, how often do we get a new credit card number?
When you lose your other credit card.
Well, usually your credit cards have a shelf life. Every 4 years, they're going to send you a new one, or when you lose your card. I think that's ridiculous. I think you should be able to go onto your credit card's website and generate a virtual number. That's good for that one transaction. So when you make an order online, like Amazon or eBay, you go to your credit card company, you say generate a random number, you copy that number, and you paste it in that transaction. And you tell your credit card company what that amount is. So right before you check out, Amazon will give you the grand total. You go to their website, you put that grand total in there, and you generate that new number, so that number is only good for that total and only for that transaction. There's absolutely no reason why we should have numbers on our cards. Put a chip in there, that chip generates a number automatically when you're in the store, and you scan it through. And it's only good for that transaction. It's pretty barbaric that we treat our credit card numbers like we do our phone numbers. Now, I know our phone numbers need to be static, because if you're changing them all the time, it's going to be hard for people to reach you. What do? We tell our friends, our new number's this, call me this, it's only going to be good for a day. Well, if everything's connected, why can't we do that at our stores? Whether it's online or traditional. Before we check out, it goes onto the computer and says, okay, this is the number we're going to give you for this particular transaction. That's it. Like an order number, if you will, blended in with the... I think somebody's going out and doing it. I think I read something a couple days ago. This is something I told my students 10 years ago, and they looked at me like your mailing addresses. We got in this debate about like Craigslist, like the Craigslist killer. I'm always waiting for one of those serial killers to come out just using Craigslist, and I know there's been like here and there, but when you guys buy something, it's got to be mailed to you, right? The post office is hurting for money. Why don't they create virtual addresses? So when you order something offline, you give them that number. That box comes in and gets scanned, it's a barcode, and it says, okay, this needs to go to Pennsylvania. Once it arrives at the Pennsylvania depot, they scan it, and it says, okay, this needs to go to Mansfield. Once it arrives at the Mansfield box, they scan it, it needs to go to the street. Do you see the levels of security it adds? This way I can feel comfortable buying anything online and not have to worry about people finding me, because that transaction is only going to be good until it's delivered. Once it's delivered, delete it out of the database. Food for thought. All right, so that's how we test our networks to make sure everything's up and running. Now you guys know where to place the blame if a blame needs to be placed, depending on where it fails at the different steps. When you get to step 5, step 6, now you're talking to your ISPs.